Welcome back. This video will introduce you to how dates and times can be processed in Python. That includes facilities for extracting date and time information from text strings, for dealing with things like time zones, and for doing math on dates, such as finding out what day of the week a particular date is. Dates and times are a surprisingly hard topic for a number of reasons. Much of this is due to different time zones, but there are other minor issues as well, such as daylight savings time being inconsistently practiced, leap years, and other things such as the old Y2K problem, which stemmed from the use of 2-digit years. But dates and times are really important to society, and so a lot of information is indexed to dates, hence why programs need to be able to process them effectively. Fortunately, there are many libraries designed to help with this, and good practices that make using dates in code less error-prone. The core library for dealing with dates and times is datetime, which includes 4 core objects: datetime, date, time, and time delta. Datetime is essentially a composite of the date and time objects. Those objects contain variables you might expect. The date object contains the year, month, and day, and the time object contains the hours, minutes, and seconds, and also microseconds. Importantly, each of these is an integer, so it's stored efficiently. However, we'll see that we can print out dates and times in location-specific formats when we need to. Lastly, there's the time delta object, and that's used to capture a difference between date times, or duration of an event precisely. Let's create some of these in a Jupyter Notebook and explore their attributes. Over here in VS Code, I'm going to explore some of these objects and discuss a little bit more about each of them. So we're going to start by importing the objects classes that we need. And so we can do from the datetime package, we're going to import datetime, date, time, and time delta. And I'll leave that up there because we imported it. And so now we can use it in subsequent cells. So let's start with creating a new date. And so I'll say example date is going to be assigned to date. And then I need to specify a year, month, and a day. VS Code's being helpful here. It's saying that the base is 1 for these. And so the smallest year you can create as 1, the smallest month is 1, and the smallest day is 1. And these roughly correspond to the year 1, the month January, and the day 1 of that month. And so 111 is a valid date. And we can, for example, print example date. Now you can see how it prints out. There's already some formatting that's happening here so that we can differentiate these. Let's make this one, let's make this 12 and this one 30, and so then we can see that this is a valid date. Now if you were to try to create a date where you had an invalid month, for example, you'd get an error. So it's basically telling you that the month has to be there. If you want to be a little bit more specific about this, you can say year equals that, month equals 12, day equals 30. And you might wonder what happens if you go outside that day. So let's say we did month 2, day 30, we get an A. So for that particular, or an error, we get the day is out of range for February. And so we have to use one that's valid. All right, this applies to times as well. So we can say the next cell down here, example time, is a time, and in this case we have to provide an hour, minutes, and seconds. Unlike dates, these are allowed to be 0, and so a valid time would be something like 0, 0, 0. And then we also have microseconds, and we can print example time. And so you can see it prints out with the hours, minutes. It doesn't actually print out the microseconds, and so that's just the stock default printout. As we'll see, we can change this later. If you put a decimal here, so like 0.1, you're going to get an error. So these need to be integers. They have to be, they are integers. They can't be float. And again, you have to be valid about it. So when you say a time, right? So you get time, and then if you put, for example, 25, and you specify nothing else, that means that's the hour, but this wouldn't be valid. Hour's got to be between 0 and 23. Okay, so you can specify as little or as much as you want for each of these, and then the defaults will be entered if you don't supply them. And so that's somewhat convenient, but I urge you to use something like hour equals 23 instead of just putting the 23 in there. And that's a little bit more specific about what you mean when you're not using all of them. Although hours, minutes, and seconds is somewhat conventional. Year, month, date, sometimes out of order, and so I think this is a good strategy so that you, if you're directly creating a date, you specify that you are, or what inputs you're assigning by name. All right, so we've seen dates and times, but we can also do an example date time. Example date time can look like this. And you can see you can specify all of them together. Now, this isn't exactly a composite of date and time. You'll see that we can get the date and we can get the time object from those, but they are in one object and stored together when you're creating a date time. And so we can specify a year. So let's do 2000, the month as January, the day as February, the hour as 5 o'clock, or actually let's do 13, so 1 o'clock, the minute as, let's say 17 minutes, or 27 minutes, and no seconds. And so this is an example date time. We can print now example date time and run that. You can see it prints out. Again, it's got sort of a stock format, year, month, day, and a time format that's 24-hour time. This is the default that you get when you print out. The last object here is a time delta, and so we can create a time delta if we want to. Example time delta equals time delta. And we can supply how many days, seconds, and microseconds. And so this is a little bit different in that it doesn't supply, for example, the ability to do months. And that's pretty typical, that a month is not a convenient way to specify a time delta because the months have different numbers of days in them. And so doing time delta, you typically will do days, or you'll typically do seconds, are the two time deltas that are typical. So that's why it's day and seconds, and then you can also do a microseconds as well if you want. And we'll see how to use these in a minute, but let's do a time delta of days equal to 1, and we can print example time delta. So you can see we can create these objects directly, and it'll say 1 day and this amount of time. Again, this is a printout, doesn't directly tell you how much, what's actually stored in there. All right, so in order to use time zones, we need to first import the PyTZ library, so I'll add that up here. And let's scroll down and create a time zone. So time zone, let's say TZ New York equal to PyTZ dot time zone. And then we have to specify a code string, and you can see there's some various ways to specify this. I actually prefer the format where you give a city. Most people understand where data was captured, but figuring out that specific time zone would be another step. And so if you know roughly where data was captured, then you can ask essentially PyTZ to figure out what the time zone for that place is. And it may actually vary on a city level, so the closer you can get down to a specific place on Earth as opposed to a general area on Earth, the better off you're going to be when working with time zones. And so I'm going to give it a code string. In this case, it's going to be America/new_York. And if you're wondering where I got that from, and so you'll see that runs, and I can print TZ New York, so we get some output. TZ New York. And so time zone just prints out exactly as we specified it. But if you're wondering again where that came from, we can do pytz.allTimeZones set, And when we run this, we can see all the different time zones that are possible. And you can open this in a full text editor if you wanted to, for example, search for it. So if I were looking for New York, you would see that there. If you were looking for Paris, for example, you would see what that's formatted at. If you were looking for Eastern Daylight Time, you can see that there's a number of different options for EDT. But EDT is not a great option, in my opinion. Normally, you're looking for a place on Earth because you're trying to use this with a specific date time. All right, so that's all time zones set. And the only real use case for PyTZ is to localize a date time. And so PyTZ is that set of time zones. It knows about the offsets relative to a standard time called Universal Coordinated Time, or UTC. And then you can use that to force a date time to have a time zone. And so I can write, instead of, once I have a time zone like TZ dot DZ New York, I can say dot localize, and given a date time, so for example, date time, let's say 2022, and 10:05. I can localize and at a very specific time. So let's give it hour 12 minute 0 second 6. So given that date time, I can localize that to New York, and that will return a new date time. So I'll say DT underscore New York is TZ underscore New York dot localize that. And if I print DT New York now, we'll see it'll print out a little bit differently. I'll print it out in the cell up here so we can run the whole thing together. And so now you can see that instead of printing out with just the date and time information, it now says minus 04. And that means that relative to UTC, Universal Coordinated Time, and right now we are offset by, at least in New York, is offset by 4 hours relative. And so we're behind by 4 hours from Universal Coordinated Time, which is in England. And so New York is offset by 4 hours on that specific date and time. And if, for example, we got rid of daylight savings time sometime, then it would still work, because on this particular date, then New York didn't have that issue. And so the date time includes, or didn't have daylight savings time. And so the date time includes the offset relative to UTC when you localize it. And this is sort of always going to be a two-step process. You should create a date time. If you're doing this manually, create a date time, and then localize it to a particular time zone. And that provides PyTZ the opportunity to adjust that date time accordingly and include a correct offset. It is possible the date time to specify the time zone directly. There is, when you do this, this TZ info property in a date time. And so you can say DT underscore New York, and you can say dot TZ info. And you can see what the time zone is. Unfortunately, specifying that directly is not recommended because of the various peculiarities associated with time zones. And so the recommendation is to localize that with a created time zone for a specific place, and be very explicit about it when you're converting a date time that's naive into a date time that's aware. So you'll notice that this didn't change the time in anything because it had no idea what it was. And so it's still the same time that we specified. It just now is localized to a specific area. But directly encoding dates isn't that common. Actually, you barely put numbers into programs directly at all. Normally, these dates come from some input or from one of these convenience functions that all create date times. So let's start with datetime.now. I'll write this out because we're going to change it a little bit so I won't store it as a variable. You can see datetime.now says datetime.datetime, and it gives us the essentially the direct representation of that datetime, or we can print it and it'll print a little bit nicer looking. And so we can see it prints out. But this is a naive date time. A much better way to use this is by specifying the time zone. So I can say TZ New York here, and this will give us our aware time zone. Remember, you can always recognize the aware time zones because they have that minus whatever. If you know you're only going to work with UTC times, you can say UTC now. And that will give you the UTC time. But I actually prefer a different way to do this, which would be pytz datetime dot now, and then you can say pytz dot UTC. And so pytz has a constant in there for the UTC time zone, and that's the best option because that gives you a very this aware time zone. It specifies an exact moment in time on Earth right now at a specific place. The last way you might want to create a date time is via a formatted string. And so pretty common that you're going to encounter more human readable strings in files, and you have to convert those. Now, a good library for importing data will automatically convert those into date times for you without you having to do a whole lot of work there, but you will on occasion need to specify the format of that string and extract the date and time information. And you can do that with this function called stirpytime. And so dt is datetime.stirpytime. And given any object, string object that contains date information in a known format, it has to be somewhat of a rigid format, but let's say someone writes January 1st, or 1, I should say, let's say 2012. And maybe they give an hour, minute, seconds. And so let's say 12 o'clock, and they might put a AM in here. This would be pretty common. After you do that, you have to specify, well, how exactly is this string formatted? So datetime doesn't specifically contain a way to automatically try to parse this. There are libraries that will automatically try to do that. But if you know that this follows a rigid format, you can specify codes that take the place of each of these and will directly match those. And so if I go over to this link here, it says the stir f time and stir p time. We'll talk behavior, and we'll talk about stir f time, which is very similar. But you can see we can match, like for example, the weekdays and locale's full name, like Sunday and Monday. We can match the month as a locale's full name, so we know that this is %B. We know that this is %D, which is the day. And notice the space that I put in here. Then there's a comma. %Y is the year. %H is the hour. %M, capital M, is the minute. And then %P would stand for this AM, PM. And so if I run this now and print DT, I should get a datetime object. Now, sometimes you're going to get an error. This is going to be pretty common, saying, hey, it doesn't match the format. Like, what did I do wrong here? And so I have a space. So we have the %D, %D, comma, and then we have a space here, %Y, which should match the year, and then another space, and that's in the string, and then %H colon %M colon %P. So try to figure out what this is. Sometimes it's going to be a little bit hard. I'm going to take off the piece here and try to match just that component and make sure that's not the issue. So we'll go there. So clearly there's some issue in this part of the string. I wouldn't take too much meaning out of this %D being blue here. That probably doesn't mean a whole lot. So let's see. %B month as a locale's full name. So that's good. Again, I'll just back it down. So January, so that's going to be %B. Let's see if that works. All right, so that wasn't the issue. January 1, and so let's do %D here. All right, that wasn't the issue. And let's add a comma and a year. So comma, space, and the year, %Y. And clearly that's the issue. So it's when we did that space and the %Y that it is throwing in the error. The error it's formatting, it's saying unconverting data. That's because I needed to use a capital Y for the 4-digit year. So now we discovered it, and we can build it up as we go. Hours, minutes, seconds, 12 o'clock AM. And let's see if this works with the ones that I used before, %h colon %m colon, and then %p for the AM PM, and now we've got it. And so you can say hours, minutes, seconds, and then this 12 a.m. gives us 12 o'clock 00. This hours, minutes, seconds is not actually correct though, because I specified AM, right? And so we would need to further convert this because this is not actually getting the correct time. And so I did that on purpose to illustrate that parsing things this way isn't really the best way when you have sort of elaborate strings. You need to know the format exactly. When it's AM or PM, you need to deal with that appropriately. So let's change this to PM and see what it does. Same time, right? So it's not exactly clear what's going on there. And so the reason it did that is because we used the capital H here. The capital H is a 24-hour clock. And so we need to use the %I if we're doing something like that. This will give us the correct PM, and AM here now gives us the correct value. So be very careful when you're typing these out. Make sure you test them. Make sure they're matching properly. Another way you can use this is the dateutil library. So import dateutil. And instead of doing this elaborate thing here, we can just ask it to parse. And so we can say dt equals dateutil dot parser dot parse. We can directly give it that string, and it usually does the right thing. So let's print dt here. Oh, dt. So it's pretty good about it. So you can see we get the exact same answer, and we didn't have to do all that work. And so I wanted to show you stir-p time because it's very exact. It's a little bit faster, but dateutil.parser.parse also is going to work in most cases when you give it a time string. All right, so once you have a date time, you can get useful things from it. So we've got a date time right now. We can, for example, get dt.second or dt.year. And so these will just retrieve those integer values. The more useful things, though, that you can get are the functions, or use the functions to get information from those. And so, for example, we can write dt.weekday. Now, I want to emphasize that this weekday starts at 0 and then Sunday and then goes up. And so 5 here actually means Saturday. And it's a little hard to read that, so I actually prefer to get the weekday by using the first function listed here, stirftime, which is the inverse of stir-p-time. So we're going to write dt.stirftime, and instead we can put percent, and then I believe %A or %A is what we want, %A, and that'll give us Saturday. And so we can see exactly that this is the Saturday string. And we can extend this out if we want. We can put %Y, M, %M, dash %D, and we can set sort of a nice printed out date string exactly how we want. And this is kind of how you should do things. In fact, we did not localize this when we parsed it with dateutil, so I should have localized it with tz New York dot localize dt and assign that to dt. And you can see now it's a local string, and so now we know exactly what time that is and exactly what day that is now that we've localized it. The dt.timestamp probably isn't what you think it is. A timestamp is a numerical value, and it's useful in a variety of computational systems because it's a very efficient way to store a date, because it kind of cuts out all of the useless things from history. And so computers only started storing stuff fairly recently, and so this is the number of seconds since midnight January 1st, 1970. And so when we're working with like databases and things like that, oftentimes we'll see these timestamps, and they're just an efficient way to store time since a particular offset. And so .timestamp gives you that Unix timestamp. It's actually in UTC, and so it is going to do that conversion there for you if your datetime is localized. And so it'll assume it's in UTC. If it's not localized, and it'll give it to you in UTC if it is localized. And so that's always a UTC timestamp. let's see. So, and then the two more here. One is as time zone. So if we wanted to convert to a different time zone, it's pretty easy to do that. So we can say dt.as time zone. Currently we're in New York, but if we wanted to know what the time zone was in Paris, we could say pytz.time zone and give Europe / Paris. And that would tell us when it was in Paris. And let's print that out nicely. And you can see that in Paris, it's 6 hours essentially earlier or later in the day from our 12 a.m. on January 1st, 2022. And then you can replace the time part of the date if you want. So if you wanted to convert that this time here that you had already, January 1st, 2022, we could say dt is dt.replace, and we'll do our and sorry, this will return it. So hour equal to 12, and we'll print dt out. And so now you can see it's 12 here instead of 0. Finally, we have time delta objects. When we subtract two date times, we get a time delta. A time delta is not much more than a number of seconds between two date times, but it can be used with other date times to offset them by certain amounts of days. For example, suppose we wanted to get the date it will be exactly 1,000 days from now. Most people probably wouldn't be able to figure that out, but with Python it's easy. We can print, let's say, our datetime.now, and then we can add a time delta of days equal to 1,000. And so if we print that out, we can see that it will be 2025, and it will be July 1st, and it'll give us the exact time, so exactly offset from right now. So time delta is really useful to figure out what day it will be a certain amount of days from now, and this also works with seconds and whatnot. We can also figure out, how much time passed between two dates. And so let's do, or how many days has it been since the start of the year? I'll print datetime.now, and then I will minus, let's do datetime, and we'll put 2022 and then month 1, day 1. This will give us a time delta, and it's been 277 days. But if we wanted to, from that time delta, I'll grab the result of this and say days, and we'll get exactly that integer 277. And so very easy to do computation on days. If you want exact values, you really need to use this total seconds, and that will account for all sorts of things in terms of leap seconds and things like that. So total seconds is an exact measurement of the amount of time passed between now and the first of the year. Or between two dates. So time delta, really, really useful in that you can essentially offset dates forward or backwards, and you can also figure out the difference in two dates, which might be important, start and finish of some activity somebody was doing. Okay, so in summary, we can use datetime and pytz to solve our date and time problems effectively. Remember that time zones are a major issue, and so a good piece of advice is to try and use UTC for storage and computation, and instead convert to a local time zone only when you need to visualize it.